what do we mean by a code and a code word? And so Mary Wooters, who's a professor at Stanford, has a fantastic course on algebraic coding theory. And if you want to dive deeper into learning about Reed-Solomon codes and the associated bounds and those topics, I highly recommend this course. There's a YouTube channel, there's problem sets, there's lecture notes. It's great. I chose a few choice slides from that in order to give a brief introduction to what we mean by a code. So stepping away from like the specifics of Starks and proofs of computational integrity and all that, the basic problem in coding theory, Alice has some message that Alice wants to send to Bob, and Alice encodes this message. So the message here is short, and it's encoded into some longer code word. But then before Bob actually receives the message, maybe there's some sort of signal noise that distorts some of the data. Maybe some entries get deleted. But so Bob's looking at this code word, or Bob's looking at this thing that was received from Alice and is wondering, what was Alice trying to say? Is the basic problem of coding theory. So here's that in a diagram. Alice is thinking of some string of zeros and ones. Alice encodes the message. Alice sends it with some potential noise, and Bob receives it and wonders about what was that original message. So here's a formal definition. A code is basically, it's just a collection of code words of a specific length using a specific alphabet. So there's an example at the bottom. The code consists of these 3 words that are each 10 letters using the standard Roman alphabet, all capital letters. Let's look at another example here, and we can get a little bit more concrete about what we mean by distance, what we mean by decoding here. So here's an example of a code. It consists of strings of length 4, where every entry in the string is either a 0 or a 1. And let's imagine that Bob, oh, sorry, before we, I'm going to skip that slide, actually. Let's imagine that Bob received this message from Alice. Bob received this string and looks at it and says, oh, there was an error here, or there was an erasure here. I can't see the second bit. Bob is able to look at this, and because Bob knows the code, or Bob knows the contents, Bob knows these 8 valid code words, Bob can look at this and say, oh yeah, I can figure out what that missing bit was. That missing bit, well, if it was a 0, then it wouldn't have been in the list. So the missing bit must have been a 1. Does that track? So in this case, if I have a missing bit, I'm able to fix it. But in this case, Bob receives 0001 and looks at the code and says, I have no idea what Alice was trying to say. This was not one of the messages that is sort of allowed. This isn't something that if Alice ran the encoding procedure that she said she was going to run, she would have gotten one of these things on this list, and what I received wasn't on this list. So you can look and say, maybe Alice was trying to send, and in fact, there's 4 possible candidates here. Maybe the 4 likely candidates here. And what I mean by that is there's 4 entries on this list that differ in exactly 1 position. The first entry differs, like 0000 differs in only the last bit. And I won't go through like finding all 4 of those, but we can detect that there's an error here, but if we try to actually decode this, we end up with a list of 4 closest candidates. So what I mean by closest, I'll go back to that slide that I fixed. The distance in this context is just the number of entries that differ. And if we're looking at something that's not valid, we can try to decode it by asking, what's the closest valid one? So sometimes when we ask what's the closest valid one, we get a unique answer, but oftentimes instead we get a list.